Hello, I am Seema and welcome to part 6 of the chapter Chemical Kinetics. Let me now tell you about the molecularity of a reaction. When I was telling you about the order of a reaction, I told you that whatever is the inner rate equation, whatever is the power to which the concentration of the reactants have to be raised, that the sum of those powers is the order of a reaction. And while I was explaining this to you, I also told you that this can only be determined experimentally. And I also told you that reactions that appear to be pretty complex, that appear to have more than 3 species, they usually are complex reactions, and they involve the presence of elementary reactions or presence of steps which are known as elementary reactions, and they are the result of a sum of these elementary reactions. Now, molecularity of a reaction is just one more way of expressing and telling you or identifying these elementary reactions. Molecularity means that it is the number of molecular species that must collide simultaneously for a reaction to take place. Now, if let us say there are 3 molecules, one molecule is decomposing, it is breaking down into smaller particles. So you need only one species for that reaction to take place. Such a reaction would be a unimolecular reaction, or its molecularity will be 1. For a reaction where there are 2 species, let us say there are 2 of them who are joining together in a combination reaction, that would be a bimolecular reaction. And a trimolecular reaction would be one in which there would be 3 different species that must collide together simultaneously, and then the reaction takes place. And beyond this usually does not take place. The molecularity beyond 3 does not exist. The reason again is the same, that for 3 species to collide simultaneously, and not only collide simultaneously, each one of those should have the required amount of energy. Each one of those should be at a certain angle with the other 2. Only then the reaction will take place. So beyond 3 species, to imagine that there would be 4, you must have studied permutations and combinations in mathematics, where you know the more the possibilities are, the more identities or entities are participating, the larger exponentially the possibilities increase. Therefore, the possibility of 4 species colliding together at right angles becomes very, very little. So from this, let us now understand what molecularity of the reaction is. The number of reacting species taking part in an elementary reaction. So now we are already talking of an elementary reaction, that if the molecularity is beyond 3, it is understood. Sometimes the molecularity may appear to be 3, yet the reaction may be a complex reaction. It may involve steps. So the molecularity of a reaction would be, of an elementary reaction, would be the number of reacting species that are colliding simultaneously. So which must collide simultaneously in order to bring about a chemical reaction is known as the molecularity of a reaction. For example, the decomposition of ammonium nitrite to give you nitrogen and water, this is a unimolecular reaction. There is only one reacting species that is required, and the molecule breaks down into smaller molecules. For this example, 2HI gives you H2 plus I2. It's a decomposition reaction again, but you need 2 moles of HI. So they are colliding with each other, and then the reaction would take place. So such a reaction would be a bimolecular reaction, or the opposite of it, that is a combination reaction. So hydrogen and iodine combining together to give you 2HI would also be a bimolecular reaction, a combination reaction where you have 2 reactants. A trimolecular reaction, an example here is 2NO plus O2 will give you 2NO2. Here you have 2 molecules of NO, so 2 species you would say, although both of them are identical, and oxygen. So you need 3 molecules, 3 entities. If they are present, only then the reaction takes place, otherwise it doesn't. So 2NO plus O2 to give you 2NO2 would be a trimolecular reaction. And greater than 3, if the molecularity appears to be greater than 3 in a reaction, it means it is a complex reaction, and obviously it has other steps, and you must try to find out what the steps are. So a molecularity greater than 3 is not possible. Let us take this example that is given in your textbook. KClO3 plus 6 FeSO4 plus 3 H2SO4 gives you KCl plus 3 Fe2SO4 whole thrice plus 3 H2O. If you look at this, you will feel that what is the order of this reaction? If you imagine counting just the stoichiometric coefficients, 3 plus 6 is 9 plus 1 is 10. It appears to be a reaction of 10th order if we counted the stoichiometric coefficients. Of course, we know that experimentally this is not going to hold true. And I also told you that when we calculate the order of a reaction, it has to be done experimentally, and if it is beyond 3, that also usually is made up of reactions that involves steps. So this is a complex reaction, and obviously it did not take place in one step, because each step, the maximum molecularity that a step would have would be 3. It cannot be beyond that. So this appears to be a 10th order reaction, but it actually is a reaction of 2nd order. So if you look at its steps, you would know that this is a 2nd order reaction. So this reaction obviously takes place in steps. Now, which step is the rate determining step? Which step is the one that will decide, when you write the rate law in order to calculate the order of a reaction, which step out of all of them would be the one that would be the most important, or the one which would determine the rate, or the one on which the rate would depend? Let us take an example. You have summer holidays and you go to the family, to your grandparents during the summer holidays. And you have all your cousins and your uncles and aunts, and you have little cousins who are just born, barely a 1-year-old. One of them is very small, and then your grandmother is really old and she walks with a walking stick. So all of you decide to go for a walk. Let it be a family walk. We'll just walk on the streets and have fun. We'll talk about pastimes or whatever you enjoy. So you all decide to go for a walk. You are young, you are in 12th standard, so obviously you are 17, 18 years old. You've got a lot of energy. And you can run, you could be really fast if you wanted to walk. But your parents are slower than you. The kids who are younger may be faster than you. And that little one-year-old, that less than 1-year-old cannot even walk properly. And your grandmother who walks with a walking stick. And grandfather who also has a certain problem and therefore he walks very slowly. Now when you go as a family for a walk, although you may be able to walk fast, you would walk slowly. Why? Because your grandmother is walking with a walking stick and you would like to help her a little walk with you. So you would slow down, you would walk beside her, you might hold her and you may go. That 1-year-old cousin of yours who does not know how to walk properly, he is standing at one place and he's just lifting his leg and he's putting it at the same place, and he's not in the mood to walk further. He does not want to put his foot ahead and put his weight on it. He's just standing there on one leg and he's just putting his leg to the floor and he's just standing there. But you want him to walk because after all it's a family ritual and you want everybody to walk, and if he can, he should. So not only you and your uncles and aunts and your parents and your cousins, but even your grandmother is waiting for that 1-year-old, because that 1-year-old is trying to walk but is not able to walk. So who determines how fast you are going to reach the end of the corner of the road till where you had planned that all of you would walk and then you would come back? Who is going to determine? You who has all the energy, your younger cousin who is about 13 or 12 years old and is faster than you, your uncles and aunts who may be slightly slower, your grandmother who's really has a walking stick, or that 1-year-old who's taking his own time and is trying to just put his uncertain feet one after the other. The one who is the slowest in the entire team will decide the speed of the team. Do you realize this? That the one who is the slowest, you will all be waiting, however fast you may be, you will all wait for the one who is the slowest, who may be your grandmother or maybe that 1-year-old. So they are the ones who will determine the rate or the speed of your walk. In the same way, when you have many steps in a chemical reaction, a complex reaction is made up of many steps. That step, which is the slowest, will determine how fast the overall reaction will take place. The other steps may be instant, but that one step is taking time. So that one step will determine the rate. Therefore, that one step, which is the slowest step, becomes kind of the most important. And it is that step with which you will calculate the order of the reaction also. Because how many species are really involved in that step would be the order of that reaction. And it would also be usually the molecularity of the reaction. The slowest step is usually the reaction with which you can calculate the order and molecularity. Usually the molecularity and order of the slowest step is the same. And of course, order may be different because order can be fractional. It is an experimental quantity, and the molecularity is a theoretical value. Therefore, there may be a difference there. But usually we find that both of them can be calculated from the same step, which is the slowest step. So the slowest step is the rate determining step. For example, we take an example of decomposition of H2O2, hydrogen peroxide. When it decomposes in the presence of iodide ion in an alkaline medium, you get H2O and oxygen. It has been found that this reaction takes place in 2 steps. So the iodide ion is actually a catalyst. And what is a catalyst? A catalyst is something, a substance that it helps the reactant to react. And when the product is formed, it leaves it. It is like a teacher, we teach you, you've come to 12th grade, we come into your life, we teach you the subject. And then when you're ready for your exam, we simply move out. And you have gained your knowledge, you have gained your education, and you get your qualification. And the teacher simply moves out. So what was the teacher? The teacher is just a catalyst. I'm only coming in, I am with you for that time when you are reacting, that is when you are gaining that knowledge. And once you've gained the knowledge, my job is done, I move out. So that is what is the job of a catalyst. And we observe that how does this reaction take place in 2 steps? First of all, the rate of this reaction is given by minus d, change in concentration of H2O2 upon dt, the time taken, and which is equal to K H2O2 into I negative, which means the rate of the reaction depends on both H2O2 and the concentration of the iodide ion too. It depends on both of them. So it is first order reaction with respect to both H2O2 and I negative. And the steps in which it takes place, it has been found that H2O2 reacts with the iodide ion to form water, and IO negative ion is produced. And this is the step that is the slow step. It is the rate determining step. The first step is the slower step. Therefore, this is the step that determines the rate. Therefore, the order and molecularity of the reaction will be calculated from the step 1. Then, what happens in the second step? The second step is a quicker step. In this you have H2O2 and it reacts with this ion that is produced. And when it reacts with the ion, it gives iodine ion back and it forms water and oxygen. Now, the overall reaction is always the sum of the elementary reactions. So these two are the elementary reactions, step 1, step 2. If you find the sum of these, you will get the overall reaction. So we find that iodide ion, which was present in the reactant side here, is present in the product in the second step. Therefore, this will be cancelled out. The IO negative in the product here is in the reactant here is in the product here, so that will also be cancelled out. Ultimately, what is the overall reaction? You had H2O2, 2 moles of H2O2, which gave you 2 moles of H2O and O2. So what was the role of the iodide ion? What was the role of IO negative? It was the catalyst. They acted as the catalyst. The IO negative and the I negative, they only were present to help the reaction take place. When the reaction took place, they simply moved out. And you see them as products, which is that they have moved out, they are separate entities again. So that was the role of a catalyst and how this reaction took place in 2 steps. And how the first step was the rate determining step because it was the slower step. So both the steps, now if you look at both of these steps, you need 2 species in both of them. So both of them are bimolecular reactions. So these are bimolecular elementary reactions, and IO negative is an intermediate. We started with I negative, but we got IO negative, which was an intermediate. What is an intermediate? Something that was formed in the middle. It was an entity that appeared in between and then it left. It disappeared in the second step. So it was produced in the first step and it was consumed in the second step. So it was only an intermediate. So IO negative was an intermediate and the first step is the rate determining step. Now from this knowledge of molecularity and order of reaction, what are the conclusions that you draw? There are three conclusions that we draw. The first one is that order is an experimental quantity. When you have to calculate the order of a reaction, you have to find it out experimentally. If you do not understand what I am saying, I would encourage you to watch the previous video, that is part 5. So the order of a reaction is an experimental quantity and it can be a fraction also. It can be 1.5, it can be 2.5, it can be 0.5, it can be 0 also. But molecularity of a reaction, if there is imagine a molecularity 0, it means there is no reactant, there is no reacting species. If there is no reacting species, how will the reaction take place? So when you have order of a reaction 0, it means that the rate of the reaction does not depend on the concentration of that particular reactant. So it can be a 0 order reaction. But molecularity can never be 0. So what do we understand? Order is an experimental quantity, it can be a fraction. Molecularity can never be equal to 0 or it cannot be fractional. The number of molecules are always whole entities, so they have to be whole. Molecularity is always a whole number. The order is applicable to elementary and overall reaction. You can calculate the order of a reaction when you say it is applicable for elementary reactions and for an overall reaction also. But molecularity is applicable only to elementary reactions. For a complex reaction, the order is given by the slowest step. And generally, the molecularity is equal to the order of the reaction for the slowest step. This I already told you, that usually the order of the reaction is calculated from the slowest step, and it is that step which gives you the molecularity also, and usually the order and molecularity of the slowest step is the same. It may be different, but it usually is the same. So this was about order and molecularity of a reaction. Now there are two in-text numerical problems. Let me do those before winding up this video. Give me a moment to write it down. Alright. Now this is in-text question 4.3. Let us read the question. For a reaction A plus B to give products, the rate law is given by R is equal to K, A to the power half and B to the power 2. What is the order of the reaction? You have to calculate the order. In order to calculate the order, you must only add the powers to which the concentrations of A and B have been raised. That's how you would calculate it. So order would be equal to, the powers are half plus 2. So what is half plus 2 is 2.5, right? So it is 2.5 or 2.5 would be the order of this reaction. Very simple. The next question is question 4.4. It says the conversion of molecules X to Y follows second order kinetics. It's a second order reaction, which means that this power is 2. And what is the reaction? X to Y. X gives you Y is the reaction, and the rate would be equal to the concentration, rate constant K, concentration of X raised to the power of 2, since it's a second order reaction. So it follows second order kinetics. If the concentration of X is increased to 3 times, how will it affect the rate of formation of Y? X was the concentration, let us say X moles per liter was the concentration of the reactant X. If we multiply X by 3, it becomes 3 times. So now the rate will be for the current concentration, and the current concentration is the rate after increasing 3 times will be equal to K, and X would be 3X. It will be 3 times X square, which is equal to K, 3 square is 9, so 9K X square would be the initial rate of formation of Y was, or the rate of the reaction was Kx square. Now it will be 9 times of Kx square. Therefore, we would say that if the concentration is increased to 3 times, the rate of formation of Y would increase 9 times. It would be 9 times greater. So this is how you would solve problems on order and molecularity. And with this, I'll wrap up this video. If you found it helpful, please give it a thumbs up. I really like getting the thumbs up. And subscribe to my channel, recommend it to your friends. Please spread the message to as many people as you can, because I really am not able to reach them myself. But you would be a great help if you could tell your friends to subscribe to the channel and come visit and study chemistry from me. Thank you for watching, and bye-bye for now.